You're listening to the Agentic Engineer podcast, weekly AI agent intelligence for builders. I'm your host, and with me as always is my co-host. Let's get into it.
Issue 7. Anthropic just published the blueprint for multi-hour coding agents. GitHub shipped parallel multi-agent from the CLI, and Meta built agents that rewrite their own source code. Not their prompts. Their actual Python. Let's go.
Quick rundown. Anthropic dropped the most detailed production architecture any frontier lab has shared. 3-agent harness, planner, generator, evaluator. Hard context resets. GN-style feedback loops. They're running coding sessions for 4+ hours without quality degradation.
GitHub shipped /fleet for Copilot CLI. Multiple agents running in parallel, dependency graphs, shared file system. And they open-sourced the Copilot SDK in 5 languages. The orchestration layer war just escalated.
An Amazon Nova Act MCP gives your agent a browser with one install. Natural language web automation, parallel sessions, built-in bot detection. Stop writing brittle playwright scripts. The big one. Anthropic published the architecture they use internally to keep coding agents productive for 4+ hours. And the core insight is counterintuitive.
Walk me through it.
Single-agent coding sessions hit a wall around 30 minutes. Context fills up. The model starts hallucinating file paths. Quality degrades. Everyone's seen this. Anthropic's answer is 3 specialized agents with hard context resets between them.
So not one agent with a bigger context window. 3 agents with smaller ones.
Exactly. A planner decomposes your spec into chunks that fit a single context window. A generator builds code for each chunk. An evaluator grades the output by actually running it. Navigating the live UI with Playwright MCP, checking results against the spec. If the evaluator fails the output, the generator gets specific feedback and tries again. 5 to 15 iterations per run.
That's the GN parallel they're drawing. Generator and evaluator improving each other through adversarial feedback.
Right. And the key decision is context resets over context compaction. Most agent harnesses try to summarize old context to free up tokens. Anthropic found that summaries lose critical details. Instead, each agent starts fresh with only structured artifacts. JSON specs, commit-by-commit progress logs, evaluation criteria. No accumulated context. No drift.
Okay, I want to push back on this. Context resets sound clean in a blog post. But in practice, you're throwing away information. What about the subtle decisions the generator made 3 iterations ago that inform the current approach? Those get lost.
That's why the artifacts matter. The progress logs capture decisions. The evaluation criteria capture constraints. You're not throwing away information. You're restructuring it into a format that doesn't degrade over time.
I'm not fully convinced. Structured artifacts are only as good as what you choose to capture. But I'll grant that it's better than hoping a summary preserves the right details.
The architecture is model agnostic. You could implement this with any capable LLM. The planner needs strong decomposition skills. The generator needs solid coding ability. The evaluator needs tool use. 3 different capability profiles, 3 different agents.
And that validates what teams like OhmyCloudCode and Deerflow have been building in open source. Multi-agent with role separation works. But Anthropic's contribution is the detail. How to structure the handoff artifacts, when to reset context versus carry it forward, how many feedback iterations to run.
If you're building agent harnesses, read the full post. It's the most actionable production architecture any frontier lab has published for long-running agent work.
Agreed. Even if you disagree with the context reset approach, the evaluation loop design alone is worth studying.
Quick hits. GitHub Copilot gets /fleet, a command that dispatches subagents in parallel from the CLI.
An orchestrator decomposes tasks into independent work items with dependency graphs, dispatches them simultaneously, and synthesizes results. Each subagent gets its own context window but shares the file system.
Non-interactive mode. Copilot-p /fleet task and --no ask user. Between this and Anthropic's harness paper, multi-agent orchestration went from research to shipping product in 1 week.
The timing is wild. Anthropic publishes the theory on Monday, GitHub ships the product on Wednesday. It's like they were both waiting for the other to go first.
And GitHub also open-sourced the Copilot SDK, public preview in 5 languages: Node, Python, Go, .NET, Java.
Custom tools, streaming, blob attachments, OpenTelemetry tracing, permission framework, and bring your own key for OpenAI, Azure, or Anthropic. GitHub is betting that the Copilot runtime becomes the default agent SDK for enterprise.
Free tier available. That's a direct shot at LangChain and every other agent framework charging for hosted features.
The enterprise play is clear. If you're already on GitHub, why add another SDK? But the open source community might resist. After the @NPR incident, trust in Copilot is fragile.
Google Gemma 4. First open model family with native agentic capabilities designed for on-device execution. Apache 2.0.
Multi-step planning, autonomous action, offline code generation, audio-visual processing. 140+ languages. Already running on iPhones. 638 points on Hacker News.
The Agent Skills feature enables multi-step workflows on mobile via Google AI Edge. The gap between cloud agents and edge agents just got a lot smaller.
This is the one I'm most excited about. Cloud agents are great, but they need connectivity, they have latency, they cost money per call. An agent that runs entirely on your phone? That changes the economics of everything.
Oh My Codex. Same creator as Oh My Cloudicode. Now targeting OpenAI Codex CLI. 17,000 stars in a week.
Structured workflows. Deep interview for requirement extraction, RAL plan for planning, RALF for persistent completion loops, team for parallel multi-agent via TMUX. Plus 13,476 stars this week.
Yechon Hio is building the workflow layer that every coding agent CLI forgot to ship.
2 viral agent projects in 2 weeks from the same developer. That's not luck. That's someone who understands exactly what's missing from the current tooling.
Light LLM. After a major supply chain breach, 3 critical CVs fixed, bug bounty launched.
The auth bypass is the scary one. They use token bracket 20 as a cache key for OIDC. 20 characters. That's a collision waiting to happen. And it did.
Privilege escalation through config update endpoint, password hash exposure. Mercer confirmed a 4 terabyte breach through the same attack chain.
4 terabytes. Through a proxy layer that most teams treat as a commodity. This is why supply chain security matters. The boring infrastructure components are the ones that get you.
Paper breakdown. Open tools. And the core insight is one of those things that's obvious once someone says it out loud.
Hit me.
Agent failures have 2 sources. The model picking the wrong tool, that's tool use accuracy. And the tool itself returning wrong results, that's intrinsic tool accuracy. Most research only addresses the first problem. This paper tackles both.
So we've been blaming the model when the tools are broken.
Exactly. Open tools provides standardized schemas, plug-and-play wrappers that normalize inputs and outputs, automated test suites that verify tool correctness before deployment, and continuous monitoring for tool degradation in production.
And the numbers?
Swapping and higher quality tool implementations delivered 6 to 22% relative performance gains across multiple agent architectures. No model changes. No prompt engineering. Just better tools.
6 to 22%. For free. Just by fixing the tools.
The biggest gains came from tools that interact with external APIs, where response format inconsistencies cause the most silent failures. Your tool returns slightly wrong JSON, truncates a response, silently fails on an edge case. The model has no chance.
This connects to something I keep seeing in production. Teams spend weeks fine-tuning prompts, when the real problem is a tool that returns a 200 status code with garbage in the body. Test your tools, not just your model.
The practical takeaway: add automated tests for every tool in your agent's toolkit. Not just does it return 200, but does the output match the schema the model expects?
Time saved, 5-minute read versus 38-minute paper. 7.6x compression.
Tool of the week. Amazon Nova Act MCP. Give your agent a browser.
Okay, I've been waiting for this one. Browser automation for AI agents via MCP. 1 install. Natural language commands instead of CSS selectors.
Your agent says click the sign in button instead of document, Query selector parenthesis quote, .btn primary auth, end quote. Works with Claude Code, Hero, and any MCP compatible agent.
The smart part is URL triage. Nova Act tries a fast HTTP fetch first. If the page needs JavaScript rendering, it opens a full browser session automatically. No wasted browser launches for static pages.
Parallel sessions let you run multiple isolated browsers simultaneously. Competitive price monitoring across sites, for example. And the install is one command. UVX Amazon Nova Act MCP --configure.
What about bot detection? That's the thing that kills every browser automation project eventually.
Built-in handling using WebBot Auth, an emerging IETF standard. For enterprise, IAM integration replaces API keys. Agent Core integration gives you serverless cloud browsers with no local Chrome needed.
So you get natural language control, automatic triage between fetch and full browser, parallel sessions, and bot detection handling, all through MCP. That's a real upgrade over writing playwright scripts that break every time a site changes a class name.
And the key tools exposed via MCP are clean. Start_browse for entry, ACT for natural language browser actions, ACT_get for structured data extraction, go_URL for direct navigation, and session management for parallel workflows.
I think this is the most practical tool we've featured. Every agent builder has hit the browser automation wall. This actually solves it without requiring you to become a playwright expert.
Open source from Amazon AGI Labs. No excuses not to try it. Agent Index Update. OpenClaw added 8,316 stars this week. 349,455 total. Down from the plus 9,937 peak, but still dominant.
The story this week is Diffie. Plus 1,354, its best week since we started tracking. The multi-agent orchestration buzz is pulling people toward no-code agent builders.
N8N at plus 964 stays close to its 4-digit streak. Crew AI at plus 564 overtook Llama Index in absolute stars for the first time. 48,126 versus 48,327. Though Llama Index still edges ahead by 201.
LangGraph at plus 588 keeps outpacing its parent LangChain on a percentage basis. 2.1% versus 0.69%. The child is growing faster than the parent.
The Microsoft consolidation continues. AutoGen at plus 299 and Semantic Kernel at plus 65 are both flat. Developers are migrating to Agent Framework 1.0 GA.
And Strands agents crossed 5,500 with plus 101. Its best week yet. Small but growing. Hot take time. And this one kept me up last night.
Meta's HyperAgents paper.
AI agents that rewrite their own source code. Not their prompts. Not their config files. Their actual Python implementation. The Meta agent can modify its own modification procedures.
The results are real. 0.710 accuracy in paper review, plus 0.372 in robotics reward design, gains in math grading. Emergent behaviors included persistent memory and self-diagnosis.
And that's exactly what terrifies me. Emergent behaviors. Behaviors the researchers didn't program. The system developed them on its own by rewriting itself.
Meta says formal verification keeps it safe.
Formal verification of arbitrary self-modifying code is an unsolved problem in computer science. That's not my opinion. That's math. You cannot formally verify a system that can change its own verification procedures.
That's a strong claim. The verification layer is separate from the modifiable code. The agent can't touch the safety constraints.
Today, it can't touch them today. But the whole point of the research is that these agents develop capabilities the researchers didn't anticipate. Persistent memory wasn't programmed. Self-diagnosis wasn't programmed. What happens when the next emergent behavior is finding a way around the verification layer?
You're describing a worst case that hasn't happened.
I'm describing the containment problem. And it's the same problem nuclear engineers face. The technology works great right up until the moment it doesn't. And when it doesn't, you can't undo it. Self-modifying agents are the nuclear power of AI. Enormous potential. But the containment problem is the whole game. And we are not close to solving it.
I think the research is valuable. Understanding self-modification in controlled environments is how you eventually build safe systems. You don't get safety by avoiding the problem.
I agree the research should exist. I disagree that formal verification is anywhere near sufficient for deployment. The gap between works in a controlled benchmark and safe to deploy is measured in years, not months. And anyone who tells you otherwise is selling something.
Fair. The research is impressive. The deployment story is incomplete. I think we agree on that.
We do. For once.
That's a wrap for Issue 7 of the Agentic Engineer podcast. Subscribe to the newsletter at theagenticengineer.waltsoft.net and follow us on YouTube at the Agentic Engineer Pod. Share it with a friend who's building with agents. We'll be back next week. Until then, keep building.